Santosh, how are you?
Hey, hi, how are you doing? I'm good, I'm good.
I'm good as well. Thank you for joining us today. It's a pleasure to have you on our live session. So, Santosh, we'll just I'll sort of get started with a few questions that we have for you today in terms of what H2 Carbon Zero does, what is its mission, what are you guys currently up to, and how are you trying to solve for the climate crisis in some shape or form. So, H2 Carbon Zero is improving energy access through building economical hydrogen fuel cells for mass adoption. So, with that introduction, can you briefly introduce H2 Carbon Zero and its mission to revolutionize the stationary power generation?
Sure. Thanks. First of all, thanks a lot for inviting me into this live session and also posting that video on LinkedIn. So, a quick background. I mean, H2 Carbon Zero. Basically, we are active in the green hydrogen space, right? So that is one of the sectors which has grown significantly over the past couple of years since the launch of the National Green Hydrogen Mission back in 2021. And prior to that, a number of different government policies globally has also kind of come up. And widely speaking, hydrogen is one of the energy vectors which gets utilized in the so-called decarbonization of so-called hard to abate sectors, right? So these are sectors which are very difficult to decarbonize using direct electrification, and that's where green hydrogen and hydrogen economy comes into play. And very specifically, we are into the stationary power generation, so we are looking to basically build devices which can do two things primarily. One, replace diesel in
Right.
diesel generator sets, so basically where we can replace the diesel generator sets with hydrogen fuel cells. That is one primary application. The second is where we can enable renewable energy adoption in the longer term with the launch of I would say long duration energy storage, which will be required once renewable energy crosses beyond a certain limit. So both these are the main applications which we cater to, and we are building hydrogen fuel cells to be catering to these applications.
Great. So, can you elaborate a little bit about the technology behind your fuel cells and how they achieve the best in class, durability or lifetime?
Sure, absolutely. So basically, our fuel cells are designed basically bottom up from a perspective of let's say looking at a number of different aspects and design together, right? I mean, we looked at what is happening in the ecosystem, who are the different competitors in the space, and from there we realized that there are a number of problems to be solved, right? I mean, right from how the hydrogen fuel cells are currently in place. I mean, in the sense that what is incumbent in nature, which is very generic in perspective, and then second at a system level. So
Right.
we have an architecture of fuel cells which is both modular application specific, right, which can cater to a number of different applications across the sectors within power generation, and through a number of, let's say, technology upgrades and technology innovation, we are basically improving things like efficiency by about 5 to 10%, decreasing capex by about 30%, and also
Yeah.
increasing the lifetime of about two times, right? So these are the different things which we are solving for from a usp perspective.
Okay. So, how does the platform sort of ensure adaptability to extreme conditions? Because I believe it's a critical factor to hydrogen fuel cells.
Correct. So basically, when it comes to critical, I mean, extreme conditions, where we talk specifically about, let's say, low temperatures, very high temperatures, or even altitude, right? High altitude conditions. These are places where a number of different alternatives, even diesel or battery-based solutions, do not work optimally. I mean, for example,
Right.
batteries in terms of charge rates and discharge rates, diesel in terms of the property of the fluid itself, 4 points of the fluid. So a lot of these things come into challenge. So
Right.
in contrast, hydrogen fuel cells have a much wider applicability that even at these extreme conditions, hydrogen fuel cells could operate. Hydrogen as a could molecule could operate. So where we have designed, I would say, a completely let's say integrated system, which includes all the ventilation and heating in itself, which is self-sufficient in nature, so that even at extreme temperatures, say minus, so we're doing a project where hydrogen fuel cells would be applied to about minus 30 degrees Celsius at 3,400-meter altitude near Ladakh, and and also
Right.
looking at projects even further away. So the design of the fuel cells in a way kind of covers for it, right? In terms of let's say hydrogen fuel cells being deployed, designed in such a way that it can be deployed in these conditions and be functional and also efficient.
Great. So, you mentioned a couple of, primary use cases for H2CO fuel cells. So, what are the key applications or industries where H2 carbon zero solutions have, you would say, the most significant impact, given the USPs that you talked about?
So basically, see, broadly, there are a couple of sectors, right? I mean, one, the most incumbent sector, what you're looking at right now, where there's a business case, there's a commercial adoption, is power generation in remote locations. So
Okay.
when we say remote locations, these are either army bases, somewhere in the mountains, islands. So basically, locations where currently there is no source or no way to generate power other than diesel, right? Diesel generators, or there is no power at all, right? There is no energy access. So, so that is like sectors number one in terms of sectors where hydrogen fuel cells we are deploying those be deploying those, where we are not only doing it in a sustainable manner because you produce water from a hydrogen fuel cell instead of carbon dioxide, as well as let's say doing it in a cost efficient manner. So that's number one. The second sector which we are targeting is so-called microgrids, right? So these are either small or large microgrids where there is a there is both a solar plant or a wind plant, there's hydrogen generation, storage, and a fuel cell. So in this kind of setup, we are able to provide, let's say, 24 by 7 renewable energy to that particular application, 365 days long, by
Right.
storing the excess of hydrogen, excess of renewable energy in basically hydrogen in the form of hydrogen, and then the hydrogen then gets converted to power. So that's like the second major
Okay.
application which we are targeting right now. In addition to these two, there are several applications where hydrogen fuel cells is touted as one of the better solutions. For example, maritime applications, in telecom
Mhm.
sites, in data centers, and those will be the subsequent applications which we will be also focusing on.
So, I think there has been a lot of conversation that has started happening lately around hydrogen fuel cells, and as a concept, it has existed for quite a while now. Since you've been working in the space for quite some time, so what, according to you, are the key sort of, you know, barriers to mass adoption or to, implement it at scale across various applications that they could be? Because diesel generators or other fuel-based systems are still widely prevalent and they're still widely used, even growing to some extent in terms of usage. So, what challenges or what hindrances are there for hydrogen fuel cells adaptability?
Definitely, great question, right? So you are right. I mean, hydrogen fuel cells. I mean, have been literally around since the 1960s when they
Right.
were used first for the space applications, right? And let's say also kind of later on with hydrogen vehicles and power generation. So broadly, if you look at it from a challenge perspective, right, there are a couple of them. I mean, one of them, of course, in the end of the day, how much ever we talk about sustainability, unless and until it is any solution is cost effective compared to the incumbent, it's very difficult to kind of make it work, right?
True.
So when it comes to the cost of the fuel cell, it's two parts, right? One is cost of hydrogen and the capex of hydrogen fuel cells. Both of them are relatively high at this point of time.
Mhm.
So and with the advent of all these government-backed policies, National Green Hydrogen Mission, global policies, US, Europe-based, the price of hydrogen is expected to decrease significantly. So as it
Okay.
decreases, we expect that the cost of electricity from the hydrogen fuel cells will also decrease, right? So that is something which will be driving the scalability. So cost being number one, right? The second aspect of a challenge is specifically on the availability or supply chain of hydrogen, right? So it is
Right.
most of the hydrogen which is currently being produced is produced and used locally, whereas now in order to kind of let's say extend the usage of hydrogen fuel cells, the applicability or supply chain needs to be also developed. So that's also going to take its own course of time. It's not going to happen overnight. So that is the second kind of bigger
Right.
challenge which is also going to happen. And then I think once these two are solved, we'll be very far away, very far further. But then the third thing, which is also kind of very specific to place like India or any developing country, is that even today, let's say I can sell a hydrogen fuel cell at a total cost of ownership basis, right? So at a TCO, I'm cheaper compared to diesel. But then most of the applications of the customers buy on, let's say, capex rather than on TCO, right? So the reduction of capex of the hydrogen fuel cells is going to be one of the major focus areas or a challenge, you may put it this way. So which needs to be also solved for. So that's where in
Okay.
1 and 3, basically, where we are playing an active role by improving efficiency, reducing capex, indigenizing the supply chain. So those are the areas where we have an active role to play, and we work very closely with our channel partners who can be supplying electrolyzers and setting up the supply chain for hydrogen in the short to medium term.
All right. And could you also touch upon a little bit about the throughput, or for the lack of a better technical term, like the energy yield that you essentially get out of hydrogen in terms of compared to other fossil fuels that you typically would use for any given application? It could be in terms of the scale of the infrastructure required to generate that amount of energy, equivalent amount of energy, or the input in terms of hydrogen that sort of goes into generating an equivalent amount of energy. So how does that compare to conventional fossil fuels?
Sure. So basically, when you compare it to, let's say, a diesel or a natural gas, right, on a gravimetric basis, that is per kg of hydrogen or per kg of diesel, per kg of natural gas. I mean, in a diesel, there's about 10 kilowatt hour of energy per kg, approximately of energy, right, per
Right.
kg of diesel. Compared to that of hydrogen, there's about 33.3, right? So almost 3.3 times energy content is there in hydrogen compared to that of diesel. Now,
Okay.
when a diesel genset operates, the efficiency of the diesel genset is not more than 20% to 25%. So at best, you get about 2.5 kilowatt hour per kg of diesel per liter. The density
Right.
is not that far away from one, from a kg of diesel. Whereas in a fuel cell, the efficiency about 50%, right? So
Right.
basically, you generate about 15 to 16 kilowatt hour of units of electricity per kg of hydrogen, right? Compared to natural gas, also similar. The ratio is about 2.8, 2.9, depending upon the lower heating value of natural gas and the quality of natural gas. But then the
Right.
energy content is much higher. And then we compare it to batteries. Let's say we are talking about 33.3 kilowatt hour per kg, whereas in a battery it's about 600 watt hour, right? I mean, which is like zero point 0.6 kilowatt hour. So it's like about 40, 50 times more energy dense compared to a battery as well. I mean, or at least 200 times when if you sorry, 20, 30 times when you compare it on a energy basis, on a yield
Okay.
basis. So that is where the biggest advantage of hydrogen is that the energy density from a gravimetric side is much higher. However, the challenge is more also on the volumetric side, where the
Right.
because the hydrogen is a very light molecule, unless you compress it or liquefy it, you're not able to store a lot of energy in a certain period of volume. That's something else. But then still, to answer your question, these are the yields and the numbers.
That's very insightful. So coming back to H2 Carbon Zero, so where are you in your journey? Are you, in terms of deployment of hydrogen fuel cells? You talked about a couple of applications that you are currently exploring. So how has the journey been so far?
So the journey has been pretty positive. I would say that within 2 years of incorporation in India, we've been, let's say, able to kind of deploy already one commercial hydrogen fuel cell and got an order from another PSU. So things, let's say, I mean, so basically, we started our to give you a perspective. We started our activities already in the Netherlands. I mean, I was there for a good 11 years there. We started our prototype development back in 2019, sorry, 2020, 2021 itself. But then we actually commercialized the fuel cell when we moved to India. So in fact, I had wrapped up the business operations over there and moved to India in 2020, end of 2021, beginning of 22. And since then, we have been commercializing our fuel cell. So happy to kind of, let's say, inform that we have been the fuel cell which we deployed in Shimla, which is for a microgrid application. It is for a public sector unit company, SJVN. That has been operational fairly well for the past 7, 8 months. And we are right now manufacturing a fuel cell which will be deployed in February, March for NTPC, which is a project in Ladakh. So
Okay.
these two applications we have already, so and in NTPC it's for a critical power backup. I mean that is the application over there. And in addition to that, we have been building our pipeline slowly but steadily, both on the public sector side, which are these microgrid or backup power kind of projects, but also on the private sector, where we are talking to construction companies for replacing diesel gensets over there, mining operations, data centers, number of companies over there, where we are looking to kind of deploy a fuel cell. So that's a journey, in fact, from prototype to commercialization, as well as getting a good fair share in the market. We are the only fuel cell OEM in India who does stationary power projects who are commercialized and have their own technology as well. And now looking forward to scaling it up from where we are right now to both deploying more and more projects in India, but also globally.
Amazing. Um, so the sector that you operate in, just by the sheer nature of it, it becomes extremely infrastructure heavy. It becomes capex heavy. So just for our understanding and the community's understanding, uh, how did you navigate and how are you currently also navigating the challenges of that come with such a sector or come with operating in a sector which is too infrastructure heavy and at the same time being an early stage startup, trying to replace certain things, trying to replace products or equivalent services that have been there for if not centuries, decades, right? So how does that uh, how do you navigate these challenges essentially in terms of
Yeah, I mean,
infrastructure development?
right. I mean, I think you're absolutely right. I mean, in terms of the capital in cost required to build these infrastructure projects and also deploy them, you're talking about not a few thousands or lakhs, you're talking about a few crores, right? So that takes its own course and time. And so there, a couple of things, right? I mean, one is purely on how we manage our, uh, manage our working capital and manage our supply chain, right? It's very important to ensure that we get, and that is what we are doing. I mean, that we are ensuring that the payment terms which we have to our debtors and our creditors is in such a way that there is a very little working capital cycle involved, right? So
Okay.
because as a young company, it's also very difficult to get any credit or let's say OD limits and those kind of things. So so we have to be very strict in terms of these payment terms, otherwise we'll not be able to service these products. So that is number one. Number two, it is also being very transparent and building the relationship with both the likes of NTPCs of public sector units or private sector companies, let's say the Amar Rajas of the world, whom we are working with, and several other electrolyzer companies, and basically explaining to them that what, the only way we can deliver the fuel cell is under these and these terms and conditions, right? And they have to support us, because if they do not, first they are not going to get it anywhere else. I mean, even if they go to buy from others, they are going to have the same terms, right? So rather they buy it from us, help jointly develop that ecosystem in India. So so a lot of effort, which is not always, I would say, easy to quantify, goes into building these relationships. So where that understanding gets developed and there's a joint support mechanism in doing so. So that is number two, right? I mean, in terms of that, and I would say number three is also, I would say, a lot of ultimately somebody has to buy it, right?
True.
And good part about here, I mean, in India, I mean, it's a very pleasantly surprised in that sense that the lead is being taken by a lot of public sector unit companies, which is in most sectors happens the other way around. The private sector comes in, the PSU is late to adopt, whereas here the PSU is early to adopt, and they are basically pushing these projects despite very thin business cases or even negative business cases, to ensure that the deployment happens and the sector grows, right? So that is
Right.
something which is super helpful, because then we do not have to explain every time what is a TST, CO, what is capex. We can directly go and go forward towards deployment, right? Because we all know that the price
Right.
is going to come down, and the only way the price is going to come down is once there is more experience, there is more deployments,
Right.
scale slowly starts to pick up, infrastructure starts to develop. So there is an overall push as well. So I think these three things are helping us, definitely. I mean, of course, not without, it's not like it's all rosy and all full of ease without challenges, but still there is definitely a good positive trend towards this.
That's good. And I'm guessing, you know, government push definitely helps on in this regard, right? Like you mentioned that, one of the very few industries where probably the PSUs adopt the technology first before the private sector comes in. And, in such scenarios, government policies or, favorable, um, you know, regulations or laws around it definitely help, right, in pushing the sector forward.
Sure.
That's that. So I have partnerships of some nature, either commercial or on the government side as well. Have they contributed to helping you build and deliver these systems to the market?
I mean, definitely. I mean, see, again, let's say that's something which I would have might have missed in the previous part. But without kind of a collaborative effort, it's very difficult to go forward, right? So we have a number of different kind of partnerships in place. I mean, right from partnership with our outsourced manufacturing partners based out of Europe, with whom we have like long-term partnerships in terms of supply, in terms of joint development of certain components of the fuel cell. We have partnerships with electrolyzer manufacturers in India, with whom we can jointly build and sell these solutions to clients who are looking for these microgrid solutions. We also have definitely partnerships with academic institutions, let's say alumni of mine and IIT Calicut or IIT Roorkee or several other institutes with whom we actively collaborate for both DST projects as well as looking to see if we can, uh, jointly build next generation fuel cells, right? From or use, deploy or expand from their current TRL levels and take it to faster commercialization. So all these things are, I mean, definitely contributing. I mean, in our kind of both commercialization as well as scale up journey in the process of it. Yeah.
Okay. So, just a couple of more questions at my end. How does H2 Carbon Zero measure its environmental impact on the ecosystem in general? And I think you mentioned the deployment in Shimla. Like, are there any metrics that you have been tracking that you can talk about?
Sure. So the good part is that the whole point of these fuel cells is environmental benefit, right? So that's a best part, right? Where let's say in a and when you talk about, let's say, very clearly, what you are doing in many of these applications is replace the diesel generator sets. Now, when it comes to diesel generator sets, there is a scope. I mean, at the site of operation, there's a scope one emission, which is from the carbon dioxide or the carbon monoxide or the SOx and the NOx of the diesel itself, right? So that is something which all goes to literally zero with a hydrogen fuel cell, because an electrochemical device as a fuel cell, the only thing it generates as a byproduct of electricity is heat and water, and heat is anyway being, let's say, used to heat up the local environment, or used in a heat integration system, for example, and then the rest is water, and it is literally pure water which can be reused in a boiler, or with some purification also be drunk, right? So in that sense, all these emissions go down to zero. So basically, this is one of the metrics we definitely track: number of hours of hydrogen fuel cells which have been operational, and number of, let's say, the emissions from a typical or an existing DG set which has been abated, right? So that is number one, which we definitely target.
Right.
The second thing is also there's a scope 2 emission or scope 3 emission, I would say, more from the CO2 which gets generated while generating diesel or while generating hydrogen, right? In case of hydrogen, the project which we are doing in Shimla or Ladakh, these are all green hydrogen projects where hydrogen is generated by splitting water using electrolyzer, and the power of electrolyzer comes from a solar plant, right? So again, the scope 2 and the scope 3 emissions are also, scope 3 emission is also zero, and scope 2 is also zero because hydrogen is produced on site and used directly on site. There's no transportation as well. Whereas in diesel, it is definitely in a refinery, you're going to produce a lot of carbon dioxide to make that diesel, and also a lot to kind of transport that diesel to a remote location, right? So these are some of the environmental parameters which we kind of cater to and, let's say, track, right, as a metric, purely from an environmental lens. Yeah.
Right. Then lastly, what's next for H2 Carbon Zero? Are there any particular projects or milestones that you're excited about?
Yeah, so I mean, definitely. The thing is that the good part of the last couple of years is that we got some traction. We got a commercial deployment. Another one coming on the way. We have established ourselves as as one of the preferred vendors of hydrogen fuel cell in India, right? Despite being a startup and despite not having a big industrial background, as some of the other larger companies do. So the point from now is basically to move much faster from a scale up and deployment perspective, right? So we have about close to about 15-16 million dollars of projects in pipeline, and the immediate target will be to convert a lot of these into real orders and deliver them and deploy them, right? I mean, so and
Right.
then these and the pipeline is across both public sector and private sector in India as well as private sector in US and Europe, right? So again,
Okay.
a healthy mix of projects which are coming up. The second target which we have is to ensure that we get some global certifications, European certifications done, so that we can be exporting our fuel cells abroad. I mean, good part is that we have designed these fuel cells more or less according to those standards. So it's more a, let's say, checklist to follow, but still that certification process takes some time. So that is going to be a second major kind of focus area. And then the third focus area, equally important, none of them being in any order, is the indigenization, right? I mean, a lot of focus over the next 18 to 24 months is to move the supply chain, which is heavily Europe focused right now, to India focused. I mean, and that's where a lot of our time and energy will be spent, which will also help both A, in reducing the cost of the fuel cell significantly, but more than anything else, let's say, made in India, and be contributing to that movement is something which we'll be looking forward to.
Great. That sounds amazing. Thank you so much for this conversation, Santosh. And it's extremely it's a pleasure to know about H2 Carbon Zero's work and mission, and I believe it's something which is much needed alternative for fossil fuels that have been existing for so long. So it was a pleasure speaking to you, and we'll look forward to H2 Carbon Zero's growth in the near future.
Sure. Thanks a lot for your questions for the session and covering us. Happy to keep you informed about our progress. Thank you very much.
We'll be in touch. Thank you so much,
Bye.
Santosh.
Thanks.
Bye bye.